50.5.
Yeah, so it'd be the halfway between 15 and 16th number. How about the lower quartile?
The lower quartile, would that be from the 15.5th value and below?
The lower quartile is like the median of the bottom half.
Oh, okay. So then you have 50.5. Do you add 1 and divide by 2 again?
What you do is n plus 1 times a quarter.
N plus 1 times quarter. Okay. Yeah.
How about upper quartile?
So then would it be n plus 1 times 3/4?
Yes.
Okay.
And sometimes you will see these called by their different names. Instead of lower quartile, median and upper quartile, they'll be Q1, Q2, Q3. How do you find the interquartile range?
Do you find the difference between Q1 and Q3?
Yes, correct.
Okay.
And that tells you how spread out the data is, the middle half of the data. Okay, this one is standard deviation. Let's try find the mean and standard deviation. Do you already know how to do this?
Not particularly.
Find the mean. How do you do that?
Oh, the mean, you add all the values together and then you divide it by the number. So
what does they gave us some summary statistics. Do you know what these two mean?
So it's the sum of x and then the sum of x squared.
Yes.
So to find the mean, we do sum of x over n.
Yes. Sigma x over n. And so it is 252 over
12.
Yes. Any idea how you do standard deviation?
I know there's a formula, but I'm not too clear. I can't remember it.
So the standard deviation of x, it is the mean of the squares minus the square of the mean. And so it's like the mean of the x squareds minus the square of the mean. So the way we just found the mean was like that. And that's the variance, and then the standard deviation, you square root the whole thing.
Okay. So what does the variance, what's the standard deviation show you?
So the reason why I took you through the little thing at the start, so you're getting ahead of yourself, but basically the median gives you the average.
Yeah.
The mean is a different type of average. And it's good to use the median to give you the middle number and cut out any outliers. The mean takes all the data into account. So there are two different types of average. The interquartile range gives you a measure of how spread out the data is.
Okay.
And the standard deviation also gives you a measure of how spread out the data is. The interquartile range cuts out any outliers. The standard deviation doesn't, but it takes all the data into account. And so they've got their pros and cons.
Okay.
But basically the mean and median match up with each other, and the standard deviation and interquartile range match up with each other.
Okay.
So try to find the standard deviation for this data.
Okay. So also sum of x squared, is that 252 squared?
Put it into your calculator.
No, it isn't.
No. So the way you would do it is you would do 17 squared, 18 squared, 18 squared, 19 squared, and add all of those answers up.
Okay, I see. Slow.
And that's why they give you this summary data. So try manually finding the standard deviation there with the summary data.
So I get 3.83.
Okay, and do you know how to get the standard deviation in your calculator automatically?
No.
So what was it? 20? What was the standard deviation?
I got 3.82.
3.82.
Yeah.
So calculator, menu and statistics. I believe it's 6.
The menu and statistics. Yeah.
Choose one variable. We've only got one variable here.
My one comes up with sub and list.
List, perhaps?
Okay. I'll write it in there. So, do I type in each of the variables?
Yeah. Do you have like an X column or something like that?
No. It says sub, then below it 1, 2, 3, 4, and then list 1, 2, 3, 4.
Oh, okay. I better swap over then. Hold on. Okay. Yeah. Okay, so I want stats. That's 2. So I press 2.
Mm-hmm. Yeah.
Sub and list. Graph, calc. Distribution tool. I think it's just list. I think we just press like 17 equals 18 equals and so on.
Okay.
Let's try that.
Oh. Yeah. I click calculate and then one variable.
Yeah.
And then,
you got your 3.83 standard deviation delta x.
Yeah.
X bar is the mean average. That's 21.
Mm-hmm.
And the other two match up, and so we know they're correct. And if we press down, it gives us the lowest value, Q1, median, Q3, maximum.
This is so useful.
Yeah, great to check your answer.
Yeah.
And they'll also say use your calculator to work it out, and so they kind of expect you to do this. Okay, part B.
An outlier is an observation which lies plus 2 standard deviations from the mean. Identify any outliers from this data. So the mean is 21. So anything that is below 19 or above 23, so 17, 18, 24 and 32 are all outliers.
What was the mean?
21.
And this is plus or minus 2 standard deviations. So let's say add the standard deviation on twice. What do you get?
The standard deviations. I just did plus 2. Okay, so 21. So it's plus or minus 7.6.
Yeah.
Okay. So it's above 28.6 or below 13.4. Right, yeah. So there aren't any below 30.4, but there's 32, which is above, so that's the outlier.
Yeah, 32 is the outlier. Yes, so standard deviation 3.83. The mean was 21 and 32 is an outlier. So you can put that in to your calculator, or you can use the formula, the square root of the mean of the squares. So the mean of the sigma x squared minus the square of the mean squared. Any questions about any part of that?
No, I got that.
Okay. Yeah, okay, let's try this one.
Okay. The ages of 9 people at the children's birthday party recorded. So, sum of x is 92. Sum of x squared is 100. Which is 28. Calculate the mean and standard deviation of the ages. So we can use the formula. So first of all, the mean is the sum of all of them, so 92 over 9, which is equal to 10.2. Yeah, recurring. And then the standard deviation, we use the formula. So we do 92 over 9 minus, no, not 92, 1,428 over 9 minus 92 over 9 squared, all square rooted.
Well done.
So that gets 7.36 as a standard deviation. Yeah. Okay, B. State with a reason whether this is an outlier. 30.
B statement.
Yeah. So we saw that the mean is 10.2. 7.36 times 2 is 14.72. So that would bring it to 24.92. And 30 is above 24.92.
Yeah.
So it is an outlier.
And C.
Suggest a reason why this age could be a legitimate age value. Because there could be a parent at the party.
And D.
Given that all 9 people would show the data and recalculate the mean of this standard deviation. So we know that one of the values was 30.
Yep.
Do we make an assumption for the age, or what happens now?
The age is 30.
But it says that all 9 people were children. So does it stay as 30? Does it get moved to something else?
I believe you just remove that person. So So it could have been a legitimate data value if it was a parent,
Yeah.
but no, it was a child. Like maybe their age was 3 or something,
Okay.
but we can't assume that, so we're just going to remove them. And so remove them, find the mean again and the standard deviation.
So we find the mean. So do we remove 30 from the sum of x?
Yes.
Okay. And would that be of 8? No. No.
Yes, correct.
But it says that all 9 people were children.
So it's in relation to part C. There could be it could have been a legitimate data value,
Right.
because
okay.
it was a parent, but actually we're told then in part D it was not a parent, it was a child, so it's an illegitimate data value, so delete it and do it again.
Oh, I see what it means now. Okay.
Yeah.
So you do 92 minus 30 over 8. So you do 62 over 30, which is about 2 point something. Yeah, 2.06 recurring.
Okay.
So that's the mean.
What's the mean,
is
sir?
it? Is it the mean?
Should be like 62 over 8? 7
Yeah, I did 60 over 30 for something. Yeah, 7.75.
Okay.
So now we need to find the standard deviation. So it is the sum of x squared. Oh, and we need to remove 30 squared from 1428.
Brilliant.
Minus 30 squared equals. So 528 is the new value.
Okay.
Is that right?
Yeah, sounds right.
Okay. So then we have the square root of 528 over 8 minus, what is it, 62 over 8, and all of that squared, and I get 2.436.
2.43, that's it. And so before, the average age was 10.2 recurring, because it was being pulled up by that outlier. Once we removed it, it went down to 7.75. And then the standard deviation was 7.36, so very spread out. But when we removed that anomaly, it went way down to 2.43, spread out. Yeah. Any questions about any part of that?
No, I got it.
Okay. So outliers, x1/2 or tick.
Outliers, they tell you the number of standard deviations, right?
They always tell you how to find the outlier, and so even for the this one, they tell you it's 1.5 times interquartile range. So they always will tell you. Sometimes it will be plus or minus 3 standard deviations, plus or minus 1.5, but they have to tell you how to do it.
Okay. That would be the only question I have.
Okay, because it changes it. This is that's interquartile range. Let me just see. See, this is all interquartile range and not standard deviation.
Cumulative frequency.
Yeah, we must
yeah, it's just something that I haven't done in quite a while.
Just want to make sure. Histograms. So I think it's good. It'd be good to do this. Okay. Let's see. I'm gonna skip something for a sec. Yeah. So copy. Okay. So for this data up here, the mean is 18.1, and the standard deviation is 1.91. For this data down here, it's this, and then standard deviation this. Compare the data of the two locations. How do you do that?
Would we just find the difference in temperature and the difference in mean and difference in standard deviation?
So that'd be good. You don't need to do that quite to that level. It's not bad.
Okay.
Just what you have to do is put it into the context of the question more than anything. So you don't need to say it. You don't need to say a difference of 2 or 3 or 2.5. You kind of put it in the context question. So what would it be in the context of this question?
Would you find I'm not too sure how to present it in this format.
The way you compare it is you compare the average and spread.
Mm-hmm.
And so compare the two means, and compare the two spreads. So
would you simply say that in Heathrow, the mean was 80.1, which is higher than in Lemming? Where it was.
So 18.1 is higher than 15.6, but in the context of the question, what does that mean?
In the question, are they trying to find a daily mean for both? Well, I'm not too sure what it's asking.
On average, Heathrow is warmer?
Yeah.
That's what they're looking for.
Oh, okay.
And now compare the spread.
Oh, so Lemming has a greater variance in temperature over August.
Yes. Lemming's temperature is more variable or varies more.
Mm-hmm.
Is more spread out, something like that. Is more spread out. I'll just say it varies more. Any questions there?
No. I think it's just understand the question.
Yes. So very common question. They want you to compare the two. Sometimes it will be compare this median and interquartile range with this other median and interquartile range. And it's the same thing again. Compare the two averages, compare the two spreads. One type of spread is the range. A better type of spread is the interquartile range. So that's the one you'd use. And usually part A will tell you, find the median and interquartile range. And then sometimes, I suppose, you could be in a situation where one is the mean and the other is the median. So those are the two averages. Those are the two you would compare. And then the other would be the standard deviation and the interquartile range. So those are the two spreads. And so those are the two you'd compare for the spread. It's not perfect. I doubt that would come up, but hopefully they'll just do the range and all that. Find the median and quartiles for both samples and then compare the two. Before we do that, let me see. Okay, yeah, this is our exam question. It's only one we've got.
Okay.
We'll do it.
So find the median and the quartiles for those samples. Oh, and they're not lined up in numerical order, which is fun.
I suppose you could put it in your calculator. That would give you Q1, Q2.
85. From there, do we multiply them by the frequency?
Correct.
So 40 times 11, which is 440. 55 times 10, 550. 65 times 18.
So before I let you do that any longer, maybe calculator?
Yeah, that's... Oh, should I just put it in my table?
But the problem is I don't know how to do. See, I can use the simpler one, much easier.
effectively win Europe. I don't know if it's done it right or not.
What did you get?
I just put in random numbers because I didn't have the data. So list 1 will be put 40, 55, 65, 75, 85.
And then you tried in the next list, was it?
11, 10, 18, 14, 7.
Yeah. And did you get 14, 7? Calc, maybe? One variable?
Yeah. I did 2 variable.
No. What did you get for 2 variable?
Something different. Yeah, 64 is the mean. Oh. I still get 64 as the mean. On 1 variable as well.
On 1 variable. Did you put the data in, right?
Yeah.
So let me put a 0 there to make sure. Let's just check the answer for this one.
Oh, now I've got 53.3 recurring.
So I think that is actually working. Let me just check. This was question 4. X bar
35. Yeah.
Hang on, no. I don't know where this thing is. So what? See, they're calling it question 4, but I think it's just taken from an exam paper. Okay, it's the very last one. So it was question 4 on that paper. So part 2, the mean is 63.4. Is that right?
We got 53.3 recurring.
40 times 11.
But if you remove the zeros from the bottom and do variable 2, then you get 64.
What were we supposed to get?
63.4.
63.4. See, I don't know how to remove
just that one. Yeah,
huh?
I don't know. I removed the 2 zeros from the bottom, and then it gave me that.
See, I don't know how to remove those zeros. Would you press delete?
Yeah.
That works. So let's delete. So
one
variable is 64.
And 2 variables 64 as well.
Standard deviation. Where standard deviation is 14.2. Nah. It's totally wrong. Saying n is 5, but n isn't 5. N is all that. All right.
Okay, we'll leave that.
That's it the long way, unfortunately. Do it the long way. I'll keep messing around with
this. Okay, so you do 65 times 18. That's 1170. 14 times 75. 1 550. And 7 times 85, which is 595. Once you've got the cumulative frequency, no, you've got the frequency of each. Do you find the cumulative frequency?
What question are you trying to do?
II.
So just find the mean, midpoint times. So it's supposed to be like total midpoint times frequency divided by total frequency.
Wait.
So you don't need a cumulative as such.
Oh, wait. So I add all the midpoints.
So like 40 times 11.
Yeah, I've done that.
Yeah.
Do I add them together?
Add all those answers up.
Okay. Okay, and I get 3805.
And you divide that by total carats, so 60 carats.
Yeah. So I get 63.4, which is the answer.
Okay. And standard deviation.
So do I square the midpoints times the frequency for each one?
Yes, so you do midpoint times frequency and square each answer.
And then I add them to each other.
Hang on, let's think about this. It's sigma. I think, no, you square the midpoint first.
Okay.
Maybe it won't matter. You square the midpoint first, yeah.
40. So I do that and then I multiply it.
Yeah. I'll just be a sec. How did you get on there?
Okay, so I got a standard deviation of 14.098.
I'd expect a smaller one than that. No, that's it.
Okay.
Sorry. Okay. And
I was looking at the next question. Would I use the 40.0978, whatever, would I use that on the mean?
yeah. But hang on. So they're making a liar out of me because all the questions have to say what an outlier is, unless to investigate if there are any outliers. So we could do the plus or minus 2.
Okay.
That's what they did. Yeah.
Okay. So I'd multiply 14.098 times 2.
Mm-hmm.
28.195. I'll leave it at that. That would be plus or minus around which number?
It's always the mean plus or minus standard two standard deviation.
So would it be plus or minus 28.195, about 63.42?
Yeah.
But how would that show us where the outliers are?
What was the mean, sorry?
63.42.
3.42.
Mm-hmm.
Plus or minus, and what was 2 times the standard deviation?
28.195.
28.195. So the minus 1, so let's say non-outliers are here in the middle.
Mm-hmm.
And then you have the 63.42 minus 28. And then on the other side, 63.42 plus. And so if it's bigger than the upper bound, then it's an outlier. If it's smaller than the lower bound, it's an outlier.
And is that in terms of the brackets in which the weight can be held contained in, in the table? The top row.
Yes, it's in terms of that top row.
Oh, okay.
Because the average is the average weight.
Yeah. So my lower bound is 35.225. My upper bound is 91.61.
Okay. And so, are there any outliers?
There could be in the first category, weight category, but we don't know how many.
Yes. So there are probably some outliers at the lower end, but none at the upper end, is what they said.
Yeah.
Okay, part 4.
Okay, so 50 carats. N equals 50. Sum of x equals. Okay, calculate the mean and standard deviation. So the mean, we just do 3624.5 over 50.
Mm-hmm.
Which gets 60.41.
Mm-hmm.
And then the standard deviation is the square root of sum of x squared over n minus sum of x over n squared. And that is 6.416 minus 3624.5 is 60 squared, so 27.83.
Doesn't like it. What did you say standard deviation was?
27.83.
Well, where is the mean there?
Oh, I've been doing it over 60, not 50.
Yes, this one is over 50.
Yeah.
Different stuff.
So the mean is 72.49.
Yeah.
And the standard deviation is 7.32.
Yeah. And okay, compare the two.
So let's see. What was that first one? That's the mean. What was the mean for the first one? 63.42. And the standard deviation, 14.09.
Yeah.
Okay. So in the first one, the mean is lower.
0 marks.
0.
Context.
So the weight is on average lower in the first batch.
Yeah.
However, it has a greater variance in weights than the second batch does.
Okay. And just don't say variance. You know, you have to be fancy about it. So on average,
should I say?
Well, on average, variety A, they weigh less, was it?
Way less, yeah.
So that was that the 63 one?
Yep.
And
the other one is 72.49.
Oh, okay, yeah. So on average, variety A weigh less. And if you wanted to, you could say exactly how much they weigh less.
Okay.
And standard deviation for the new one was 7.3 and the other one was 14.
Yeah.
So they weigh less. But what about the spread of their weights?
So the first batch has a greater spread than the second.
Yeah, but variety A's weights are more spread out.
Yeah.
More spread out. They are more varied, or they vary more, but just don't say bigger variance.
Okay.
Because variance is an actual. It loses the context. I think it's like saying the standard deviation is bigger. Variety A has lower average than variety B or equivalent. Variety A has higher variation than variety B or equivalent. On the whole, average, more spread but not higher range. Yeah, you see a higher range now. Okay, and at least one of them has to be in the context of the question.
Yeah.
Yeah, so that's standard deviation anyway. What would you give yourself for that, Gregoire?
Out of what? A mark out of 10?
Like X out of tick, X a half or tick.
I think I'd still need to do just a bit more practice just to make sure that I consolidate it in my mind. Yeah.
Let's just see. We might be able to get one more. So that was the comparison. See, that's so the comparison you're actually okay for. I mean, that was a particularly tricky one.
Also, I have a question which kind of works off of certain indices.
Yeah.
So I was doing a practice paper for an entrance exam, and it told me to simplify 11 square root of minus 1 to the power of 11.
So do it with your calculator?
But isn't the square root of minus 1 a complex number, an unreal number? And it was in a non-calculated test as well.
What was it? Minus 1, was it?
So it was 11.
Yeah.
Square root of minus 1 to the power of 11.
What is minus Oh, minus 1 to the power of 11, like that?
Yes, but it was square rooted.
I suppose it would be 11 root minus 1. Was this? Are you doing complex numbers?
No, I haven't started it, but I'm wondering if it's coming up in a test paper.
Shouldn't be. Are you doing further maths?
Not, no.
Where did you see this question?
It was an entrance exam for an American university. You know, the SATs even.
Will you be doing that exam?
Perhaps.
The answer they're looking for is 11i. The square root of
11i.
minus 1 is called I.
Okay.
And I found a thing on the internet where actually it tells you how to get this thing. Dog, cat, and a frequency. No, that doesn't tell you how to do it. We want... that's one variable. Recursion. That's still not it. Maybe it's not here. No, looks like it's not. Oh well. Let's see. So I'll just see. Estimate number of boys with that. Median histogram. Can I estimate the mean of 100 girls? Histogram. Mean and are only estimates. Yeah, so this is, I mean, yeah, I think just practice it. I mean, they're all the same, really, aren't they? So this one, you would have to calculate estimates of the mean and standard deviation. So let me get my worst calculator. See if there's any possibility. Pick up one of these. Well, or just check the internet for the thing. So the x is the midpoint. So 750, 1250, 1750, 2500, and 400. Frequency 7, 22, 26, 18, and 7. AC to save it. Option, variable calculations, and standard deviation is there right away. Average is there right away. So all the stuff with the x squared, multiplying them, is just all cut out. It goes straight to that. And so if you can find how to do that on your calculator, then it'll be great. How was that for you, Gregoire?
It was good, informative. Yeah, I think I'll just try and find how to do the standard deviation on the calculator.
So we can do it from a list, but we just can't do it from a frequency list. Or, I mean, the really terrible way to do it. Let me just take a look. So the really terrible way to do it would be if we went to our list. Did these delete? Yeah. And we did 40 11 times.
Oh dear.
5, 6, 7, 8, 9, 10, 11.
And then you do the next one.
55 10 10. It's actually not too bad. Wow, 65 18 times. Uh, 75 14 times. And then 85 7 times. And then what do we do again?
Then you click exit to go back. Yeah. Then calculate.
63.4
and it has it.
14. Yeah, there we go.
Wow.
So actually that wasn't too bad. Yeah.
Okay, I'll make a note about that.
Yeah. Or I'm sure there's some way to do it. You just have to find it, do the frequency thing. So do you want to do the indices and surds next time?
Yeah, maybe that could work. Otherwise, I'll tell you during the week.
Okay.
Yeah.
Any questions for me in general?
No, no, I
All right.
don't.
All right.
Yeah.
Well done, Gregoire. You did great. I look forward
Thank you
to
very
chatting
much.
again next time.
Thank you. Bye.
All right. Have a good one. Goodbye.
You too.